Good afternoon, participants. Good afternoon, participants. We'll be starting the session soon.
Hi guys, am I audible?
Yeah.
Yes, sir.
Yes.
Okay. So I hope the systems are set up. Any doubts on that, guys? About the virtual machine setup, etc. If you have any doubts, please mention it on the chat box. If not, then we can proceed with the fundamentals of ROS. Because now we are going to see something called as fundamentals of ROS, where we'll get a brief introduction to ROS, what exactly it is, exactly for that. Okay. So yeah, we'll get to know what is ROS, how and where it is used. Next. So yeah, once again, any doubts on the basics of Python, basics of Linux? Any doubts? There are. Do let me know. Okay then, let's get started. I'll share my screen. Okay, I hope things are visible. So, what is ROS? ROS is a framework that acts as a middleware between your communication, like when you want to give some certain instructions to the robot, and the primary OS, like Windows and all. Okay. So ROS is firstly open source, so no licensing fees. What all ROS offers as a framework, you can do communication with your robots, within the ecosystem. There's perception, collision avoidance, motion planning, navigation, industrial interface, etc. Okay, and the full form of ROS is Robot Operating System. Okay, the full form of ROS is Robot Operating System. Now let's discuss what is the main goal of ROS. Like, what is the pain point that ROS is trying to solve? ROS is stopping you from reinventing the wheel. Okay, now what do I mean by reinventing the wheel? Let's say you have built a mobile robot. Okay, the mobile robot is working perfectly fine, everything is good. Now, on this mobile robot, on top of this, let's say you want to add a robotic arm whose job will be, along with a camera, whose job will be to detect objects and pick and place at certain positions. Okay, that's the job of your robotic arm. So what's the end application of your robotic arm? Is perception, that is judging what the object is, where it is, and picking up and placing it. Okay, that's the end goal or the end application of your robotic arm. Now, let's say you start without ROS. Let's say you start without using ROS. What do you have to do? You guys have to build the basic setup as well. Okay, you have to build the basic setup, the basic kinematics, the basic movement of the robot from scratch for the robotic arm. But let's say there is a node available for the same, okay, for all the basic needs of your robot. What you can do is you can grab that node and integrate it with your existing ROS package. And doing so, it will save you time on the basic robotic arm movements, okay, the basic setup, the basic kinematics, etc. And what you can focus on is the end application, that is attaching a camera, figuring out the image processing and perception, and then how you can pick and place the object. You get more time to spend on the end application rather than the basic stuff or the groundwork or the scratch work that you need to do. And that's a very key element from ROS, that you can grab multiple things from various sources, put it together and build on top of that. And that's exactly what ROS is meant for. Okay, so ROS provides a standard for robotics and robotic software development that you can use on any robot, Okay, so due to this, there is a lot of innovation that drives. Rather than doing the same work again and again, we can focus more on innovation. We can focus more on the new things, on the new stuff that people haven't done. We can focus on that. Okay, and yeah, that is the main goal of ROS, to stop reinventing the wheel again and again. I hope that's clear. Okay, moving on. Now, what exactly is ROS then? Okay, so in a sentence, you can say ROS is an open source tool or a software that acts like a operating system. But ROS is actually a meta operating system. Right? It acts like an operating system. It is not an operating system. So ROS is an open source meta operating system for robots. Okay, it creates a hardware abstraction layer, so you can communicate with the hardware. It has a low-level device control. You can use the message passing capabilities, etc. There are tools and libraries as well written, and you can write and run codes in C++, Python, etc. The best OS that supports ROS is Linux, but it's also capable to run on Mac, iOS, Android, Windows as well. But the best supported one is Linux. In that, you can use the Ubuntu distribution. And now on, you see that ROS has been accepted all over the place, right from colleges, schools, to research industries, to industrials, manufacturing, etc. Now, you guys heard the term meta operating system, but what does that mean? What exactly does it mean? So, meta operating system is not like your existing operating system. Okay, so let's say you have a primary OS Windows. On top of that, you will run ROS. So what ROS will do? ROS will take advantage of all the features that a primary OS gives, like file manager, message passing, error handling, etc. So it will use all these capabilities, and it will create an ecosystem where you can write software for the robot, plus you can also deploy software for the robots. Okay, so meta operating system means it's not exactly like your traditional operating systems like Windows, Linux, Android, but it provides an essential function for developing robots, where you can write software for the robots. At the same time, you can deploy them in your robots, which leads to creating an ecosystem where you have everything at one place. That's one of the objective, one of the many advantages that ROS uses. Hence, it's also known as meta operating system, where it acts like an operating system, but it isn't. It actually takes advantage of what the existing operating system has and builds on top of that, or creates an ecosystem on top of that. Okay, I hope the concept of meta operating system is clear. Right? Just to put it in one line, it's like an operating system, but not an operating system, and it uses all the key features from your parent operating system to create an ecosystem where you can write and deploy codes in your robot. I hope things are clear. So your meta operating system is actually a middleware. A meta operating system is actually a middleware that has to communicate with your primary OS, with your hardware. It can be your Arduino, Raspberry Pi, or the sensors, or the device managers, or device drivers, etc. Plus, it also has to communicate with the packages that you create, how they are fused in your robot, etc. Right? So Meta operating system is the middleware over here, whose responsibility is to communicate back and forth with the system, with the hardware, with everything. And here, the middleware is ROS, right? A robot operating system is the middleware who is going to communicate with your primary OS, with your hardware, with your Arduino, Raspberry Pi, its device drivers, sensor device drivers, your robot, your packages, everything. So it's like the translator in between, where you from one end you pass in the instructions, it takes the instructions, it passes it on to your robot, and vice versa, right? So it's exactly like working as a middleware. Now in ROS there are other tools as well available that we can take our advantage on. So the first tool I would like to say is Gazebo. Gazebo is a simulation. It's a physics-based simulation where you can model your robot, get it inside Gazebo, and build an application around it. Okay, like let's say I want to create a mobile robot along with a robotic arm and pick and place objects. I can do that. In fact, if I want a production line or a factory outlet where a robotic arm is stationary situated near the conveyor belt and picking up objects and adding a depth camera, if I want to do at this level, I can do that as well, right? So in Gazebo, you can do basic stuff as well, like small robots, small drones, small mobile robots, to a factory outlet as well. Gazebo has that level of capabilities to do, which makes it incredible because you don't have to spend any money on the hardware. Like let's say you are facing a problem, okay, and you want to quickly test out a solution that you have. You can model a robot, you can add the certain parameters to it, and you can quickly shift to Gazebo, get your model inside Gazebo, calibrate and fix things, and there you go. You can immediately test your hypothesis without adding any external hardware cost. Hence, Gazebo is really a good tool to use along with ROS from a simulation point of view. Now you might ask, is Gazebo the only simulation tool? No, there are other simulation tools as well alongside Gazebo. But Gazebo is one of the most referenced and one of the most used simulation tools, I think, along with ROS. Okay. Then there is another tool. The second tool is known as RQT graph. Okay. Now, what is RQT graph? If you look, it displays the information flow, right, or the control flow in another word. So what is this? This is a visual representation of your compute graph. Okay, RQT graph helps you understand how the data is flowing from one point to the other. Over here, you can see that the robot serial interface is connected with your scan is connected with passing out on to your AMCL, and so on and so forth, right? So it helps you understand how your system is working. It helps you understand how your data is flowing within your system. Now this is again a very useful tool when you want to debug, when you want to understand the system in a deeper context, right? When you want to know all the intermediate steps, where the data is going, how the data is going. Let's say there is some error that you're facing, so you can pull up your RQT graph and look at it and understand where the data is misplacing or what can go wrong. Stuff like that. Okay. So that's RQT graph for you. Then we have RViz. RViz is a robot visualizer. Okay. It helps you visualize the sensor data, or in another words to put in, you can have a look at the environment from your robot's point of view, and RViz helps in doing that. RViz is a visualization tool. It's providing visualization for your data that your sensors give you. It's an incredible visualization tool. Why? Because you can use RViz alongside simulation or alongside real robot. Now RViz doesn't care where your data is coming from. It can be simulation, it can be real robot. It will visualize the data to its best. And that's the power of RViz, that you can pass in data from the simulation, it will visualize. You can pass in data from real robot, it can visualize. Right? And it's a really good tool. Now, why do we need visualization? Because if you want to program a robot in its most efficient way, you need to look the environment from the robot's perspective. Let's say you have attached a LiDAR, okay, a LiDAR sensor. Now the LiDAR readings, you are expecting a 360-degree readings, but for some reason, let's say it's just giving you 180-degree. Now, if you don't visualize this, how would you understand? Right? If you don't understand what's the error in the sensor or in the sensor data, you won't be effectively programming your robot. Hence, you need the visualization over here. The visualization will tell you how the sensor is behaving, how the sensor data is being acquired, how the robot is behaving to that data, etc., etc. And you can build code around this. So RViz being one of the powerful tool that it doesn't consider whether it's data from your simulation or it's data from your real robot. It will give you a nice visualization. So any doubts until now? All good? Things clear? Gazebo, RQT graph, RViz. Any doubts? Okay, let's move ahead. So these are some components or elements you can see in your RQT graph, right? Like nodes, topics, etc. In the further sessions, you'll understand what are nodes, what are topics, etc. Right now, I'm just giving you things to consider what you might be learning ahead. What is this? This is a heat map, you can say, of how the ROS community has been spread all over the world. This is actually a fairly older data, I suppose. It's maybe 2019, late 2019, early 20 somewhere, 2020. Yeah. So point here is that the ecosystem or the ROS community is being spread all over the world, and it's right from schools to companies to research institutes, almost everywhere. And it is being adopted very rapidly. In fact, in India, a lot of hardware startups and hardware early stage startups are also moving towards ROS, or from day one they are accepting ROS. Why? Because ROS gives you the advantage of fast prototyping. Okay. In fact, it gives you the standard to also deploy your system on a production level or a manufacturing level. Hence, its adoption rate is pretty high. Now then the question comes, where do you get started? Where do you get started with ROS? So the very first place to get started is ROS Wiki. Okay. ROS Wiki is like the Bible of ROS. It's the official documentation of ROS. Okay. So you can start from this ROS Wiki. Second is ROS Answers. Now what is ROS Answers? ROS Answers is similar to Stack Overflow. So for people who don't know what Stack Overflow is, it's a forum, it's a website where you can ask questions and someone from the community would answer you. Okay, and this is similar to ROS Answers. In ROS Answers, it's similar. You can ask your queries, someone from the community will answer it, and if your query, if the question is very similar that somebody else has already asked and has an answer to it, great. You can just look at the query, you can just look at the answer and implement it. Then ROS News, the name itself suggests that it would be the updated forum for ROS. So it can be a new update, it can be your a new distribution, or it can be any major conclave, event, conference, etc. So if you want to stay updated with ROS, I would suggest go check out ROS News. Okay. So these are the three main things or three main resources where you can get started with ROS. Now let's speak about the history of ROS. So ROS was started in 2007, okay, in the Stanford AI lab. In 2013, it took over or went on to under the management of OSRF, that is Open Source Robotics Foundation, and today it's being used by many companies, many industries, etc. From that point, there are many distributions out there. Okay, there are many distributions out there in ROS. I have a list of them over here. Okay, so this is the latest one, ROS Noetic. In fact, prior to this, I want to tell you another thing is there are two major ROS. One is ROS 1 and another one is ROS 2. Okay, so these are the list of distributions for ROS 1. So first they started with Turtlebox, CTurtle, and so on and so forth. One of the two most recommended right now and stable are ROS Melodic and ROS Noetic. These two distributions are a part of ROS 1. Okay. And I'll give you the list of ROS 2 as well. This is the distribution list for ROS 2, out of which the stable releases are Foxy, okay, and Galactic. ROS Foxy. This is ROS 2. Yeah, I will zoom it up. Yeah. So ROS 2 started with this, and today we have the two stable releases, that is ROS Foxy and Galactic. Okay. This is for ROS 2 and this is for ROS 1, where we have two again stable releases, Melodic and Noetic. Now then your question would be, why do we need two ROS? Wasn't one satisfied, or doesn't ROS 1 fulfill all the needs? Well, no. To understand this, let's understand when ROS was built, it was majorly as a tool for research and development, from what I understand, and it was majorly built for fast prototyping, so people can easily get into ROS and start their research, work, application, whatever it is. But slow and steadily, people got used to it. It was so robust that people tried to implement on a production level. When you go towards production level, there are a bunch of things to take care. Major things like security was also an issue, and a lot of things around it. Hence, this led to the development of ROS 2. And ROS 2 is meant to support almost everything out of the box, right from security to package management, a lot of other things. Now you would ask that, then do we have to learn ROS 2 again from the scratch? No. If your basics of ROS 1 are rock solid, it would barely take you like 2 to 3 hours or even less than that to get an up and running with ROS 2. Why? Because the concepts, the fundamental concepts remain same in ROS. Okay, fundamental concepts remain same in ROS. So you don't have to worry that, okay, now once I study ROS 1, then I have to study ROS 2. No, just get your basics right with ROS 1. You can easily build the bridge from ROS 1 to ROS 2. Okay, I'll share the links as well in the Notion document that I have shared, so everyone can access it. Okay. Yeah, so ROS did start like almost a decade ago. It's been more than a decade. And this is a small video that I want everyone to have a look. And we'll discuss about why I want you guys to have a look at this. this video, if you would have looked carefully, there are bunch of robots, right? Basic robots like mobile robots or small robotic arms, complex robots like biped or drones, or those underwater robotics, etc. Right? Or quadrupeds, etc. My point here is ROS is pretty much compatible with almost every application that you might think of. So that brings us to that ROS is pretty limitless. It's just your imagination what you would be building off or what problem you want to solve with. Okay, and ROS is pretty flexible. You can also integrate external factors into this. You can build external application that can be linked with ROS, and you can form an ecosystem where they coexist. So yeah, that's the history of ROS. Okay, any doubts until now onto the history of ROS, or any doubts from the distributions, ROS1, ROS2, anything? Any doubts? Okay, I think things are good. Okay. Now, another obvious question. Okay, we have a question from Sarvesh. Is ROS can be integrated with virtual reality? Yes, ROS can be integrated with virtual reality. In fact, Unity, hold on, let me just show you the thing what I'm talking about, Unity. So if you see this, I hope my screen is visible. Yeah. So Unity is a game engine. Okay, it's again a physics-based game engine. Now, ROS and Unity are working together to bring robotics for virtual reality. Okay, this is an ongoing thing that they are doing. Okay, so both the giants, Unity and ROS, both are working together to make this happen. There are a few demo packages, but they are under development yet. But yeah, there is a lot of scope in that, in virtual reality and ROS and robotics as well. Yes, any other questions before we proceed? Let me just check the comment box. Okay, I think we are good. Okay, so yeah, I was saying another obvious question, that is ROS the only one? Is ROS the only development framework? Is ROS the only meta operating system out here? Well, answer is yes and no. Because as you can see, even Microsoft got into this. Microsoft back in 2008, 2009, they got into this with their robot development studio. Unfortunately, I don't think so they are around, and there were other frameworks as well, but ROS stood out to be the best out of them. Then the question is, why? What makes ROS so successful? One reason can be that the other frameworks were not pretty good from a fundamental point of view, or had a very steep learning curve, I guess. Then there can be other frameworks that were used internally among teams, among industries, so they were never open source, so people never got use them to that limit, or maybe there are a few that are under licenses, stuff like that. Whereas ROS, I believe, is becoming, or has become, the giant over here is due to its open source capabilities. So since it's open source, a lot of people can contribute to that and fix the issues, get new features, etc. Right? So even if you want that, hey, this feature is not in ROS, maybe I can build it, you can make a pull request on GitHub and go ahead with that. If your changes are accepted, you are a contributor to it as well. Right? So to the answer of that, why ROS has become this giant, is this, that It's been into open source since day one. A lot of people have contributed to its growth and development, and secondly, it has a learning curve, but it's not that steep. Or and the fundamentals, the architecture that's based on, it's pretty good. It's pretty robust. Okay, then the question is, how is ROS used in industries? So there is something called as ROS Industrial altogether, right? And why did this exist, or why did this came into picture? Because at times when people started using ROS on the industrial level, there were a lot of problems they had to face. Because see, robots did exist into industries prior to ROS as well. And what were the problems at that time? A lot of different languages. There was no interface for languages like C++, Python, or no toolbox, right? No standard procedure for problem solving, etc. And there was tons of difficulty. When ROS came in, it made a standard platform. It made a platform that you can build on top of that. You can build things on top of that. Right. So ROS Industrial helps with that. It communicates like a bridge between the older systems and the newer ROS systems. So you can write code in ROS and it will communicate with the older systems and make things happen. So I again have a small video on to the progress of ROS Industrial, what all things are done. Let's have a look at that. Yep. So that was about ROS Industrial. So you can see from the videos that people have achieved things like robotic arm, like pick and place, welding, and bunch of other things that go from fabrication to manufacturing and a lot of other things. Now the other advantage of ROS Industries is, let's say a candidate is working in a company called ABB, right? ABB Robotics. Tomorrow that candidate has to shift from, let's say, ABB to KUKA. Now, since the company uses ROS to an extent, there wouldn't be a lot of groundwork to be done when you shift to a new company, since platform, the development platform remains same. And this is one of the major advantages, because prior to this, what used to happen, every company has its own standards, has its own programming languages or interfaces, you can say, that were used to develop these robots. Right, so there was a lot of friction when someone used to transfer from one end to other. So these were some things about ROS Industrial, and these are some companies that use ROS Industrial to some extent. So you have big names like ABB, Bosch, BMW as well. Yes, any questions? Any questions around ROS, on the fundamentals, basics of ROS, anything, and whatever that we have discussed until now? Can yes, ROS can be connected with MATLAB as well. In fact, just a second. If you see the MathWorks documentation, we have a ROS toolbox as well, where you can connect ROS and MATLAB. Yes. Any other doubts? How long does it take to get a good grip on ROS for a beginner? It depends on your pace, but I'll suggest within a week or two, or within a week actually, or less than that, you would be good to. What's the name of which website, Vashish? Which website are you speaking about? This ROS network? Okay, I'll share it. It's mathworks.product/products. I'll share this in chat as well. I guess this is what you mean by that. And to add up to your answer, that how long will it take? So this program is all about that. We are giving you a fast-paced approach onto how to get started with ROS, you can quickly and easily get started with ROS. Because see, the knowledge to learn ROS is out there on the internet. But the problem with that is it's not well articulated from a beginner's point of view. And hence, we come in where we give you the exact tunnel vision that these are the things you need to do, learn ROS. And as you guys know, we at Rigbytel Labs also have our own mentorships that revolve around this. So yeah, within a week or even less than that. In fact, in the upcoming session as well, you would get the grips of understanding of the fundamentals of ROS. So you can quickly get started. But yeah, since you're speaking about the good grip, a week is more than enough. Any other questions about ROS, ROS2, anything? Okay, so we're pretty much done with the basics introduction to ROS. I would like to know, how is your systems going, like the system setup? Is it done? Is anybody facing any issues? Because in the upcoming session we'll require that. Okay, in the upcoming session that would be a hands-on session where we will do some hands-on on ROS. So let me know if you face any difficulties while setting up your systems. Please share the morning session. Yeah, Dr. Amit, I guess you can contact, or somebody from the coordinator can get in contact with them for the morning's recorded session. Just to show you once again, your system should look something like this, where you have your virtual machine and system should be up and running, so we can get the hands-on session done. So we have time. We have some time until then, until the next session. So if you have any doubts. Sure. there are any issues, do let me know. RAM as in, are you speaking in terms of your PC? Recommended is 8, minimum 6. Yep. Let's say if you're speaking about the virtual machine, you can say 4 GB of RAM is okay. Login is not coming. Suraj, can you please share your screen so I can have a look at the issue? Yeah, please do that. Sorry, I was on mute. Yes, your screen is visible, Suraj. I was saying, can you please close your close your virtual machine, the top right X. Yeah, please close that. Yeah, power off. Yeah, just click OK. Yeah, I guess it's closed, right? So please open your VM again, virtual machine again, VMware. Sorry. Yeah. Now click on open virtual machine. Yeah, click on that. Now select the extracted OVF file. No. Wait. This is the mistake that I guess you're doing. So if you see, all the 3 files are not extracted in the same folder. Okay. So I would suggest please re-extract it. So close this, cancel this. Yeah, cancel this. Yeah, and now please open a window where you have downloaded the zip file. Okay, where is the zip? It's not here. No, I don't think so. You need to download again. It would be downloaded somewhere. Just check your downloads or maybe some other directory. Because if you have extracted it from somewhere, it should be there. Can you go back? Open your VM. Let's try it. Open your VM. Yeah. Virtual machine. Yeah, the second last option. Yeah, yellow. Yeah. Yeah, now go to open a virtual machine. Okay, this is on desktop, right? So check if you have it on your desktop, the zip file. No, this is the OVF file, but we also need the rest of the two files as well. So close this, do one thing. Close this and so yeah, close your VM. Yeah, close it. Okay, so we have, can you do one thing? Yeah, that file, the tortoisebot.mf, that file, the OVF file, and the orange icon, just get that all in one folder. Just create a new folder over here. Yeah, create a new folder. Name it TTB, whatever. Yeah, just get all that three things in one folder. And the last blue icon as well. Yeah. Now open your VM. Yeah. Yeah. Now do open virtual machine. Now go inside that folder. Desktop, right? Yeah. Yeah. Select that file. Open. Okay. Now, yeah. Now give it a name. Yeah, and import. Okay, until then, anybody else see an issue? Install workstation, but I'm not getting steps to create. Okay, Nandini, have you installed workstation or workstation player? There are two variants actually. Both. Okay. I would suggest open player. Okay, and then do these steps, and make sure you have extracted all of them in one folder. Okay, so Nandini, can you please share your screen? Let's have a look. Yeah, and your screen is visible. Yeah. Now can you please open VMware Player? Yeah. Click on Open Virtual Machine. Okay. Select that. Click on Open. Yeah. Give it a name. Yeah, import. So this option was never there. Like you didn't get this option. Yeah, can you click on, yeah, just click on play. No, not edit, just click on play. Straight away click on play. Wait, take some, setting it up will take some time. Yeah, there you go. I can put in the password as tortoisebot. TORTOISEBOT. Yeah, and sign in. There you go. Okay, what happened? Yep. Okay, issues resolved. Sure. Yeah, Mr. Suraj, are you done on your side? Is your system up and running? Still extracting? Okay, fine. If you have any issues, just ping me or anybody else facing any other issues with their setup. Let's see, if you have any doubts, any queries regarding the setup, let me know it now itself. So then we won't be facing any issues while we do the hands-on session. That's at 2:30. So do let me know about that. Yeah, Mrs. Suraj, can you please share your screen so I can have a look? Yeah, click on play. Click on play. Okay, this should start. It's okay. You can ignore that. That 3D. You're using Windows 7, right? Sorry, it's 8. Okay. Um, the thing is, I doubt if this supports on Windows 8. So, Dr. Amit, actually, Galactic is ROS 2, so it's completely different zone. I would suggest you please get this virtual machine setup, or if you can have an access to Ubuntu 18 and Melodic would be great, because Galactic is a ROS 2 and things work in a bit different way in ROS 2, and what we are focusing today is ROS 1. And as well as Mr. Suraj, can you get access to a Windows 10 operating system by any chance? Because I doubt this is because of the support of Windows 8. Is there a scope for that? Yeah. Okay. Fine. Okay. Sure. Sure. Mr. Suraj, you can try on another system, and if you have any doubts, you can let me know. Yeah. Um. Any other doubts? Coordinators, like if anybody reaches out to you for the doubts, do let me know. And how do we proceed from here? Anybody from the coordinating team is present over here? Prateek or someone from the team? Yes, anybody else? Any doubts regarding the system setup? Hey guys, if you have any doubts, do let me know. And in the next session, you be learning about Node, Publisher, Subscribers, which is like again a very core fundamental topic of ROS. So make sure before that you get your systems up and running. Okay. And if you have any doubts, do let me know. I'm here on the call. Yeah, I could. So the instruction goes in this way. Firstly, I'll share this link again. Okay. Okay. So download this link firstly. Sorry, open this link, and then you can see two things to download. First one is the download, that is a preset virtual machine image that we have prepared for you. Second one is a VMware workstation software that you need. So download this, install this. When you download this preset file, it comes like something like this. Okay, it's a it's a zip file. So make sure you download and extract the zip. Now once you extract the zip, I will just open a new one. Just a second. Yep. So this is the window you would get. Okay, then just click on open, then go to the folder where you have extracted the files and just select the OVF file and click open. So this will ask you for the name and storage space. So provide the name and storage space and click import. Okay, all the instructions are provided over here. That says first download, then extract all of them in one folder, download the software, VMware player. Okay, then select the open virtual machine option, select the OVF file and hit import. That's it. That will get your system up and running, and you can then use the password to log into the system. That's it. Okay. If you have any further doubts, do let me know. how to open virtual machine. Have you installed it, Mr. Pramod? Have you installed virtual machine? If you have, just click your Windows search and
Yes,
just search
sir.
for
Yes, sir. Shall I share my screen?
Yes, please do that.
Sir, are you able to see that?
Not yet. Yeah, it's loading.
So this I have
Yes.
created.
Yeah, awesome.
So this
Now
is
just click on-
this is a download for Windows, alle? This is
Yes.
not for Ubuntu, not for Linux.
No. This is just for Windows. So click on open a virtual machine. Yeah. And have you extracted the files that I said previously?
So not yet. I have downloaded, but
Yeah. Then I will first suggest you to extract. Cancel this. Yeah. And now go to the location where you have downloaded it.
where I have downloaded. Is here? Is it this one?
No, not this. No. I'm speaking about the preset image file, that you have. Okay, just click on files. I can see one file. Click on the bottom taskbar, file manager,
Here. This one?
yellow color. No, left.
Here.
Yeah, just listen. Just click on this file manager that is just beside your browser.
File manager.
Can you just scroll over there? Scroll. Okay. No, we can't see that. Okay. Now, did you download the first link from the Linux and Python documentation that I've shared? Basic documentation.
Is it
Yeah,
this one?
the first one. Yeah, exactly. Have you downloaded this?
So I think that is what is this one. Not this one, yeah?
No, it's not this. It's not this.
Oh, okay. Okay. So this one.
Yeah, just right click and download. Last option. Yes. Yeah, download anyway. There you go. So this will download, then extract this in a folder.
Okay.
Okay,
This
and
are
then you
extraction.
Yeah, after extraction, then you can click on open virtual machine, and then there will be a .ovf extension file. Just click on that and import. That's it.
Oh, okay, sir. Okay. That I have to go through this one, open virtual machine.
Yes. That you have to go via that. Yes.
Yeah. Okay, sir. Okay. I'll try it up and then
Yeah.
I will
You have
come
it.
back with
Yes, please.
So it will take some time.
Sure.
Okay, sir. Thanks.
Thank you all. So we'll begin the next session by 2:30. We'll be sharing the link by 2:15 in the WhatsApp group. So please, I request all of you to join at that time. Thank you. I hope all of you have enjoyed the session. Thank you, sir, for giving an insight on various fundamentals of ROS. Thank you, sir.